healthy. Today we start with our second project management lecture. Today is the October the 4th, 2021. And we're going to continue looking at, we continue our project management, project and process management approach by considering projects and processes by considering projects and processes as networks. And this word is going to be very important, a network. So first we describe what a network is, and then we prove that both projects and processes can be described as such. Intuitively, a network can be mathematically described as a graph. Okay. A graph is a set, a group of nodes and edges. Okay. You can express it like this. Graph is a set of nodes and edges. Okay. You can describe graphs, can be described visually. Okay, so one example, for instance, we can say we have a network with, let's say, 4 edges, 1, 2, 3, and 4. 4 nodes, sorry, and then we have some edges connecting these nodes. Okay, so we have nodes. The set of nodes is the set of 1, 2, 3, and 4. The set of edges is the connection between 1, 2, 2, 3, 1, 3, and 3, 4. Okay. We talk about two sorts of graphs. One is direct graph, when edges have let's say when edges are arrows, so they have a direction, or indirect graph where edges are not arrows. Okay, so both both can be taken care of and considered. So we can look at a project, okay? Let's say a project. And our project management tool called DCPNA has a do part, which is the so-called Gantt diagram. Okay, which is, as we saw the other day, this is time, and this is a set of actions or work packages that have a timely relationship to each other. Okay, work package 1, work package 2, work package 3, work package 4, and so on. And this means that you need to be done 25% with work package 2 in order to start work package 3, for instance. And you need to be ready with work package 3 by 50% in order to start with work package 4. This is just the way it's represented in a way that, let's say, you can also write like this. And in this way, you can think of this timeline as a network where you put work package 1, and then you say is connected to work package 2, and is connected to work package 3, and work package 2 is connected to work package 3, and work package 3 is also connected to work package 4. Okay? And this two graphs have the same information. If we start like, let's say 2 and 3, we say here 25%, and 1 to 3 is 50%. Okay, so these two graphs, these two graphics have the same information. The second one has a characteristic that we can describe this as a graph of the project for package 1, 2, 3, and 4. Are the nodes, and the edges are work package 1, 2, work package 2, work package 1, 2, work package 3, work package 3, 2, to work package 3, and work package 3 to work package 4. Okay, this is kind of a project graph representation. Questions? Is it understandable? It's okay if you give feedback, it helps me. You understand it? Should I repeat something? You're cool? Good. Well, anyway, I guess that's okay. It's not rocket science. We can then continue, let's say, with a description of the project, of the process. So now we have the process management. C, B, D, and A. Okay. And in the plan, we have the current state of the process. And let's say we have here the time. The arrow of time. And here we have the process owners. And here we have the work packages, the process steps. With material flow and information flow going on. I don't know. Okay, so just so with what is the you can see very fast that this is also a network. Okay, a different network where you have your process steps as one is connected to two, two is connected to 4 and 3, 4 is connected to 5, 5 to 6, and 6 to 7, but also 4 is connected to 7. So in a way, the same kind of information, only that now we are able to describe this as a graph, which is very useful, as we will see now. Graph of a process. Let's say the nodes are 1, 2, 3, 4, 5, 6, and 7, and the edges are, let's say, directed 1 to 2, 1 to 2, 2 to 3, 2 to 4, 4 to 5, 5 to 6, 6 to 7, and 4 to 7. Okay? And this information is relevant for our purposes because we have just described processes and projects as networks. Okay? Any questions about this conceptual work? Gibt es Fragen? So, wir können sowohl Projekten als auch Prozessen als Netzwerke darstellen. So, why is this important? because now we can create some metrics around our projects and processes that before were not possible. Okay. So the first metric, so now we create some metrics. Metrics to measure network. Whenever I say network, I can say process or project performance. Okay. Let's say we are going to define certain KPIs that we can universally use to measure our performance. And the first one, there are three. The first one is the average path length. Average path length, or in short, APL. Okay, the average path length is the average distance between two nodes of the network. So if we take two nodes of the network, let's say here, we want the average path length to be the average distance between any two nodes in the network. Okay? So a question for you, do we want the average path length to be very big or very low? Hello? Wollen wir diese mittlere Abstand zwischen Knoten klein oder groß haben? Nobody? Okay. We want our average path length to be as small as possible. The smaller the average path length, the faster value will flow through the network. Okay, this is logical. If our average path length is low, is small, then the distance between any two nodes is small, so we get information, material, or value in general fast from A to B. So the math behind it, the average path length equals 1 divided by n, okay? Times n minus 1 times the sum of all the nodes, or the distances between all the nodes. So what does this mean in words? Why is this the average? This is the maximum number of edges of connections in the network. Why is n times n minus 1 the maximum number of edges in the network? Somebody tell me. If I have a network of n elements, 1, 2, 3, 4, 5, pam, 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 n, okay? And each node is united to all of them, all of the rest. I have a maximum of n minus 1 relationships for each one of the n nodes. Okay. And this term, so this is the maximum number of edges, and this term is the distance between all nodes. Distance meaning the distance between, now let's say here in this network, what is the distance between 1 and 3? Well, 1, 2, because I need 2 steps. Or between 1 and 4, 1, 2, because I need 2 steps. Between 1 and 5, 1, 2, 3, okay? So this is the distance between the nodes. So the average path length is APL equals 1 divided by n times n minus 1 sum on I on j of all the distances. Okay? Okay, questions about this? No. Okay, the second important KPI is the clustering coefficient, or in short CC. Okay, measure of how cluster groups form the network. To follow the same, we want same description as above, we big. Here. We want the clustering coefficient to be as big as possible, so that information is effectively shared in the network. Okay, let's say people from one department share information, and so they build a group within the department. Okay, so mathematically speaking, the clustering coefficient equals 1 divided by n of I of the clustering coefficients of all nodes. Is the clustering coefficient of each node. No worries, we will make an example later. So 1 divided by n. And this is typically a question that I usually ask in the exam. So this is 2 times L sub I divided by K sub I times K sub I minus 1. And this is something that you need to think about a little bit. L sub I is the number of connections between the neighbors of node I, and this is a definition, and K sub I is the number of neighbors of node I, which usually is called the degree of the node. Okay, let's make an example before we continue of these two metrics so that we get a little bit cozy with them. So before I continue, let me paint it again. Clustering coefficient is equals to 1 divided by n 2 times Li divided by Ki minus 1. And as I said, this is usually a question that I ask in the exam, so you better paint yourself some examples and do some exercises like we're going to do now, because in the exam it should go fast. So ich wiederhole, dies frage ich in der Regel meistens in der Prüfung. Ihr solltet euch selber ein paar Beispiele selber malen und versuchen, den APL und Clustering Coefficient zu gestalten, und zwar selbstständig. Okay, so first example, very simple. Let's get the network. A reports to B, and B reports to C, and B reports to D, and C reports to D. Okay. Get APL and clustering coefficient. So how do we do it? How do we do it? Well, first APL equals 1 divided by n minus 1 times sum of I and j, all the distances. Okay, so 1 divided by n is 4, is the number of nodes, A, B, C, D, okay? So 4 times 4 minus 1. So you're cool with that? Yes? Hello? Are you cool with that? Yeah. Good. Then what is the distance between node A and B. Hello. Look, I can go super fast. If you don't interact with me, I can go super fast, and I'm also cool with that. So, do you want me to go super fast? Wollt ihr, dass ich schnell gehe? Keine Reaktion. Okay. Good, then I go faster, I guess. So the distance, yeah. So please interact. Just interact. Just make your microphone on and just interact. Try to answer the questions. Okay, just it's easy. If you don't know, it's okay. We're here to learn, but just try to interact. What is the distance between A and B in this graph? How many steps do I need to go from A and B to B? I don't see the chat, so please talk. Hello? What is the distance between A and B? 1. Good, thank you. What is the distance between A and C? A and B is 1. A and C is 2, yes. So the distance between A and D, 2, very good. So the distance between, I am done with A, so now I go to B. The distance between B and D, B and C, sorry. 1, thank you. The distance between B and D, 1. The distance between C and D, and we're done. 1. Very good, thank you. So that's about it. Okay, this is the average path length. 1 divided by 12 times 1 plus 2 plus 2 are 5 plus 3 are 8. So 8 divided by 12. Okay, so we get, if we divide by 4, we get 2 divided by 3, I guess. 2/3, 0.6 period. Okay, so do you get the concept? I need to do 1 divided by n times n minus 1, and then measure all the distances from all the nodes to all the others. Okay, so A to B, A to C, A to D, A, B, C, D, and then B to C, B to C, B to D, and C to D. Okay? Understood? Good. Well, the clustering coefficient is a little bit trickier. Okay, so I paint the graph again here because the clustering coefficient is a little bit more complicated. So I have the same here as above, A to B, B to C, B to D, and D to C. But now I have the clustering coefficient, which is 1 divided by n, the sum of I on I, 2 times Li divided by Ki, K minus 1, Ki minus 1. Okay, this is a little bit trickier. So I first do 1 divided by n, so 1 divided by 4 times. So first for node A, okay, node A, 2 times L sub I are the connections between the neighbors of node A. Who are the neighbors of node A? So we have here A. Who are the neighbors of A? B. So B is not connected to B. Okay, so there are no connections between the neighbors of A. So L sub I is 0. K sub I, it doesn't matter because we already have 0. Okay, so the clustering coefficient of node A is 0. Clustering coefficient of node B, 2 times, okay, this 2 comes from here, number of connections between the neighbors of B. Who are the neighbors of B? Who are the neighbors of B? A, C, and D, right? So how many connections do we have between these 3 nodes? 1, right? We only have 1 connection between the nodes A, C, and D. So this number 1 is L sub B, means there is only 1 connection, the one between C and D, between the neighbors of B. Okay? Is this understood? Yeah? So divided by K sub I, K sub B, how many neighbors do I have with B? I have 3 neighbors. So this means that K sub B means that B has 3 neighbors. Okay, times 3 minus 1. Okay, I'm really trying to go slow, but you need to interact, otherwise I don't know if you understood. Let's take clustering coefficient of node C. Okay, somebody wants to do it with me, please. It's the best way to learn. Hello. Somebody want to do it with me? Hallo? Ich höre nichts, ganz weit weg. Endrit. So can you talk louder? I can't hear you very well, so sorry. A little louder, maybe? Yeah, better. Oh, tell me, what do I write? Not so much. So I need to write here a 2. Okay, this is the same. Okay. Then how many neighbors does C have? C has how many neighbors? B and D, right? How many relationships do B and D have to each other? 1. Very good. So here, this upper part is the same. Divided by how many neighbors has C? Only 2, right? So here is a 2, and then 2 minus 1. Okay? So this number is k sub c, means that C has two neighbors. Okay? And this number is L sub C, means that there is only one connection between, which is going to be B to C, between the neighbors of C. Okay? Understood? Very good. So let's do together also then the D. Come, just tell me what should I... 2 times 1. Okay, good. Divided by? Very good. So, and this whole thing, it just equals 1 divided by 4. And then I say just this is 1/3 plus 1 plus 1. Okay, so this is just 2 1/3, so 7/3, 7 divided by 12. Okay. So are you cool with that? This is the clustering coefficient, and the this is the first example, and the average path length. Does it make sense? Please make sure you get yourself some more difficult examples so that you are ready for the exam, okay? Because in the exam you will need to go fast and there is not much time to think about. You need to do it quite agile. Okay. So another example. I give you another example that you can do yourself. For home, if you want, okay, this is just voluntary. So 1 reports to 2, reports to 3, and then 3 reports to 4, reports to 5, reports to 6, reports to 7, reports to 8, reports. So can you tell me, and it's always the same, okay, just can you tell me average path length and clustering coefficient? Okay. So, any questions? So you can do that for yourself at home. If you feel motivated, you can write me with your solution, okay? And then I share with you my thoughts. That's just voluntary. You can use the WhatsApp channel for that. Anyway, now we want to continue with the next concept, which is a more project management concept, which is the concept of Slack. Okay. This is defined as the amount of time we can delay an activity and not influence the overall duration of a project. Okay. So we learn how to calculate the slack of a project for each activity. Let's say we have a Gantt diagram like this. An example like this. Wait, I'll do it prettier. And so we have our packages here, and now we have our packages. A and B duration here, and C here. Let's say all the way here, and then we have D here somewhere. Okay, so we have A. This is the time. Time slots, and this is the A work package, B work package, C work package, D work package. And the dependencies are like this. I cannot start B without being done with C. I cannot, without being done with A. I cannot start I start B and C at the same time. Okay. And then I start B. I start B. No, I start D once, only when B is done. And also I start D once C is done. Okay, so both B and C are the conditions for D. In other words, our graph is A, B, C, D, just like before. Okay, so we can calculate the whole clustering coefficient, average path length, and stuff like that. So these are, let's say, weeks. Okay, first week, second week, third week, fourth week, fifth week. Okay. So can we delay? Question. Can we delay an activity without delaying the overall project. Okay. And for this, we describe four, in order to, well, this is the definition of a slack. We define four metrics, which are the early start, early finish, late start, and late finish. Okay. Early start, early finish, late start, late finish. Early start, ES, is the earliest possible start. Early finish is the early start plus the duration of the node. Late start is the latest possible start, and late finish is the late start plus the duration of the node. So what is the early start for A? The time 0, because it cannot start earlier. Okay. The early finish is time 0 plus the duration. The duration is 1 week. Okay. Can I delay A? Can we delay A without delaying the overall project? Make sure you understand this shit correctly. This is important for your exam. Can I delay A without delaying the project? If I, let's say, if I start A on the week 3, what happens with the rest? Yeah, so I cannot delay A. So the latest start without delaying the overall project is 0. Okay? And that's why the late finish is the late start plus 1 week, the duration. What is the early start for B? Because B needs to start after A. What is the earliest start for B? Week 1, very good. So what is the early finish? Is week 1 plus 2 weeks, because it's a duration of 2 weeks. Okay, so 3. Can I delay B without delaying the overall project? Yes, very good. For how long? 1 week, very good. So now let's say we say here, I could theoretically start here. Okay, I put it like this. In week 2, let me paint it with a different pen style. Theoretically, I could start B later and nothing would happen. Okay. So the latest start of B is 2, week 2. And then the late finish is 2 plus 2 weeks, so 4. Okay. This is important shit for your exam. What is the early start of Z? Week 1. Okay. Cannot start earlier because I need A to be finished, or I need B to be finished. The early finish is 4 here. Okay. Can I delay C without delaying the rest of the project? Hello? Now, if I delay Z to week 3, then because D depends on 3 on Z, if I move C 2 weeks to the right, then D moves 2 weeks to the right, and I delay the whole project. So the latest start for work package C is 1, and then the same the late finish by the same logic. So and the early start of D is 4. The early finish for D is 5. And I cannot delay D without delaying the overall project, so 4 and 5. Okay, so it's fixed. So the slack is defined as late start minus early start, or similarly, late finish minus early finish. Okay, so if I put another column here, let's say, let me paint it here again, A, B, C, and D, and then I say here slack. What is the slack of work package 1A? Is late finish minus early finish. 1 minus 1 is 0. Okay, sorry, is 0 here. The slack of work package B is 4 minus 3, or 2 minus 1 is 1. And then the slack of C is 0 because I cannot move it, and of D is 0 because I cannot move it. Okay? So there is a rule here. Is this understood? Hello? Is this understood? Okay, very good. The fact of the matter is that you can talk about the critical path of the project is the group of work packages which slack equals 0. So here the critical path of this project is A, C, and D. And this is going to be for sure one question in the exam, okay? So I will ask this for sure. Make sure you understand this shit. Okay. So I give you one example for home. And of course, this is just voluntary. Let's say work package. Description. Predecessors. And duration. So work package 1, 2, 3, 4, 5, 6, and 7. Description is lease site, hire workers, hiring, arranging, installing, phones, I don't know, okay, install IT and move into Office. So the predecessors is this 1, 3, 4, 5 and 3, and 2, 6 and 4, and the duration 1, 5, 1, 2, 1, 1, and 3. Okay, so with predecessors I mean that, let's say A is the predecessor of B, okay, or B is the predecessor of C and stuff like that. So I want you to be able to calculate early start, early finish, late start, late finish, the slack of each work package, plus the critical path. Okay, so and this is a typical question for your exam. Make sure you understand and make yourself several examples and are able to solve these things very fast, okay, because in the exam I will use the dimension of overcomplicating things, or by giving you very long exercises, so I see who has studied, okay, not only understood but also understand and implement fast. Okay, so any questions please about today's input? We have learned that projects and processes can be described as networks. We have understood how to describe project and process management as networks, as graphs. We have described two metrics to describe network performance: average path length and clustering coefficient. Make sure you give yourself several exercises to and repeat the exercise, and let me know if you want to check the solutions you get. Then we have learned how to calculate the slack of a project based on the early start, early finish, late start, late finish logic, and the critical path. Okay? So, questions, please. Hello? Are you cool? No questions? Good. Well then, I'm done for today. All the information is uploaded in the YouTube side. If you have any questions, ask on the YouTube side with input of your minute and second for the question, okay? Of course, you can contact me on WhatsApp anytime with your solutions for your exercises.